All right, so if you're watching this, that means you're choosing to do some optional additional math work. Good for you. It'll benefit you greatly, I believe, when you take calculus next year, be it in college or here taking the AP with Miss Betlem or Miss Neiman. First 3 days, we did a little bit of slope of secant line. We did slope of tangent line, both at the limit definition and the power rule. Now, day 4, we're going to do some more power rule, a little warm up, and then we're going to find equation of tangent lines, and we're also going to find equation of normal lines, which from physics you guys have talked about. Normal lines used for refraction of optics, lenses, angles in, angles out. All right, I'm not going to do all 3 of these warm-ups. I'm only going to pick one, which is example 3, because that's the meatiest of the 3. Before I can find f prime of 1, we got to find f prime. Before we find f prime, we got to rewrite this exponentially. 5 over x squared is 5x to the negative 2. X square root of x is also known as x to the 1/2. We haven't found the derivative yet. We haven't used the power rule. Now we're going to. F prime of x equals negative 2 times 5 is negative 10. X. Negative 2 minus 1 is negative 3. Negative 1 times 1/2 is negative 1/2. X. 1/2 minus 1. 1/2 minus 2/2 is negative 1/2. But I don't like to leave it there, especially when I got to evaluate at 1. I'm not quite sure what f prime of 1 would be. So what I'm going to do is rewrite it again. F prime of x equals, what's negative 10x to the negative 3rd? Negative 10 stays up. X to the 3rd moves down and becomes positive. Minus 1 over 2. X to the negative 1/2 moves down, and I'm going to call it radical x. That's a better version of f prime. Now if I want to find f prime of 1, I'm just going to plug it in there. Negative 10 over 1 cubed minus 1 over 2 radical 1. 1 cubed is 1. Negative 10 divided by 1 is negative 10. Square root of 1 is 1 times 2 is 1/2. Negative 10 minus 1/2 is negative 10 1/2. Or what would that be? Negative 21 over 2. All right, so that's nice power rule. Again, got to be good with exponents, both fractions and radicals. Now let's move on to some new stuff. All right. Equation of tangent lines. So we've already known how to find the slope of a tangent line. And we're going to refer to that as MT. And that just equals f prime at that value you want to find. Well, for equation of a tangent line, you need 2 things. You need the slope and you need the y-intercept if you use y equals mx plus b. But there's another cool form of the equation. You might have remembered seeing this in Algebra 1 called point slope. In calculus, they call it Taylor form. And what that is when you're given a slope, which we'll find, and you're given a point, x comma y, y minus that y point, we'll call it y1 and x1 so we can distinguish, equals m times x minus the x coordinate of the point. And we can leave it just like that. We can leave it in that Taylor form, that point slope form. Now, what's a normal line? Well, a normal line, if the tangent line goes like this, the normal line goes like that. Meaning what? Normal line is perpendicular to the tangent line. So m normal equals the perpendicular upside down capital T of m tangent. Okay? So when we find the equation of a normal line, it's going to pass through the same point. So the point's not going to change. It's just going to have a new slope. And what's the relationship between the slope of 2 things that are perpendicular? Negative reciprocals. So for example, if the tangent slope was 1/2, the normal slope would be negative 2 over 1 or negative 2. All right, let's get working. Right, the equation of a tangent line of f of x equals x squared plus 3 at the point, at the x coordinate, pardon me, x equals 3. So let's first find the slope. Got to find f prime. Use the power rule. 2x, nice and easy. The derivative of a constant is gone. Now we're going to evaluate that f prime at 3, and we get 6. What did I find? I found the slope of the tangent line. Now, I need the ordered pair. I need the point xy, and I just have the x. What does that mean we're going to do? We're going to plug 3 into the function to find the y coordinate of the point. 3 squared is 9 plus 3 is 12. Now we're ready to rock. Let's put it all together. Y minus the y coordinate, 12, equals slope 6, x minus the x coordinate 3. And again, if you like to pretty that up and get it into mx plus b form, do it. You don't have to. All right, let's move to the normal line of this same curve, okay? Now, if we were going to sketch this, we can, because we know what this function looks like. It's x squared plus 3, a normal parabola with an upshift of 3. And we just found the equation of the line at x equals 3, so we found this equation right here. Now we're going to find this equation. Perpendicular to that tangent line. Let's label normal and tangent. We did tangent in red. We're going to do normal in blue. Notice the point 3, 12 is on both lines. So the 3 and the 12 aren't going to change. What is going to change? The normal slope equals the negative reciprocal of the tangent slope. What's the reciprocal of negative 6? Pardon me? Negative 1/6. So let's put it all together. The equation of that normal line. And I like Taylor form better because you can see that the point is the same, because the y-intercept up here would be very different than the y-intercept of that other line. But the point's the same. All right. Very well. Let's keep moving. Find the equation of a tangent line at x equals -1. I think we know what to do now. So we're going to go slope equals f prime of x. Power rule. -2 times 3 is -6. X squared. Derivative of a constant is gone. F prime of 1, pardon me, of -1. Equals -6 times -1 squared, which is 1 times -6 is -6. There's the slope. Now we need to find the point. Well, we already know what x is. Now we just got to find y. How? Plug it into the original. Whenever you're looking for a point or position, you plug into the original. Let's see. -1 cubed is -1 times -2 is 2. 2 minus 5 is -3. Put it all together. Equation of the tangent line. Y plus 3 equals -6 parentheses x plus 1. Absolutely. And if we're going to find the equation of the normal line to that same curve but at a different point, we need to find the slope at -2. By plugging it into the slope rule, the derivative. -2 squared is 4 times -6 is -24. And remember, that's the tangent slope. Now we want to find the normal slope. Negative reciprocal, 1/24. We have the point given to us this time. Y minus 11 equals 1/24 x plus 2. Take a look at that, see if it makes sense to you. We'll see if we can do maybe one more, and that should be, maybe 2. Okay. Find the equation of the tangent line. Ooh, a little more challenging to find the derivative. So what do I do first? Find the slope. How? Turn f of x into exponential form. 8x to the -3rd minus 1. Now we can apply the power rule. -24x to the -4th. Again, the constant's gone. I like to rewrite back without that negative exponent right there. Now we're going to evaluate f prime at 1. -24/1 is -24. So the equation of the tangent line, y minus 7 equals -24 x minus 1. Since we got it, we might as well do it. So what is the normal line at the same point? Point is point, negative reciprocal slope, and x coordinate. Beautiful, beautiful, beautiful. All right, last question. Find the equation of a tangent line to the curve where the slope equals 0. So we don't have the point we're looking for. We're actually looking for the point, but we know that the slope is 0. Well, what does slope equals 0 mean? Well, that means a horizontal line. And the only place a horizontal line can occur is at a max or min, relative max or min. Here or here. So how do we go about finding where that max or min is? Well, we can go back to old school. We could factor that if it was factorable, but it's not. So pull out an old tool from the toolbox, the quadratic formula. Oops. B squared minus 4AC, got ahead of myself, sorry. All over 2A. Now that finds the two roots. This finds the axis of symmetry, also known as the x-coordinate of the vertex. So if I said x equals, what's b? 8. So what's negative b? Negative 8. What's a? 1. So 2 times 1 is 2. So the x-coordinate of the vertex of that function is negative 4. Now to find the y-coordinate, I just plug 4 in. Pardon me, negative 4 in. And I get negative 19. So what do I know? The point that, in this case, it is a happy parabola, so it's going to be a min. The rel min is negative 4 comma negative 19. Now we have the point, we have the slope. So we could write it as y plus 19 equals 0, x plus 4. Well, 0 times anything is anything. You could just say what the y value is negative 19. That's the horizontal line. So that's a different type of finding an equation, working backwards a little bit. It's going to be very valuable when we do our next two things on the first derivative and the second derivative. All right, well done, folks. That'll call it for today.